Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to learn when a charged particle moves in a combined electric field and magnetic field, then it experiences two forces. One is the electrostatic force and one is the magnetic force. Okay, and the resultant of this force is called what? Lorentz force. So we are going to learn about the Lorentz force, and after that we will see the cases behind the Lorentz forces and we will solve the questions also. Okay, so let's go through it. Under the Lorentz force, you can see here Lorentz force is the resultant of electric and magnetic force that acts on a charged particle moving in an electromagnetic field. That means electric field also there, magnetic field also there. Here I have taken one situation. So here you can see very well there is one magnetic field inside the board, that means along the negative z direction. After that, the charged particle Q is moving with velocity v along the which direction? X direction. So here we can write very well the charged particle. Basically I have taken here the positive charged particle. It will experience the force Q times V cross B. Is it? Fm equal to Q V cross B. How to get the direction? You have to curl your finger from the first vector towards the second vector. That means V to B. So this will be the direction of what? This will be the direction of the magnetic force experienced by the particle, and this is the velocity. Okay. Now students, after that, let's see, there is the one electric field in this direction. Electric field in this direction, and you know very well the charged particle will experience how much force here? You can see here the electrostatic force, we can write here Q into E. Okay, that means for the positive charged particle, the direction of the force will be along the direction of the field. So let's take the field in this direction. So what will happen? The electrostatic force will be also in the same direction. Now let's take in this direction only. I am telling you the electric field is there. So in the same direction, what is there? Electrostatic force is there. Now the resultant of Fm and Fe, this is Fm, this is Fe, this is the one parallelogram. Okay, so here we can tell here this is the resultant force. I am writing here F. Okay, so we can write here this is called the Lorentz force here. So this vector F, I can write here what? Fm magnetic force plus the electrostatic force. If I put the value, it will become here Q V cross B, okay, plus Q into E. Now even you can take Q also common also outside, and let's take, I have put here in a big bracket V cross B to keep the things separate plus vector E. Is it? So this is called here what here students say, this is called here the Lorentz force here. Okay, and remember that here sometimes we need the magnitude also. No? So let's take, I will write here, if in case we have to write here the magnitude of the magnetic force, so it will be what here? Remember that here QVB sine theta, where theta is the angle between velocity and the magnetic field. In this situation it is how much here? 90 degree, but they can give any angle. Okay, if I talk about here the electrostatic force, it will be here Q into E, just only magnitude I have written here. Okay, and this is all in a vector form, and this is the main Lorentz force here. Kindly see very well. Is it? So the resultant of magnetic force and electrostatic force is called what here? The resultant force. This is only called the Lorentz force here. Okay. Now students, after that here, if I talk about here the cases of the Lorentz force. Okay, so see here, under the first case, see, when V, E and B are collinear, that means velocity, electric field and magnetic field are collinear, then moving charged particle will not experience magnetic force, but it will experience electric force here. Okay, so let's take here this I can see here, see, this is the pink color. Now let's take, I have taken here, this is the magnetic field here. Okay, and let's take here, this is the, now this blue color line is there. Now let's take, I have taken here, this is the electric field is there. Okay, so here what can we tell here? This charged particle is there. Now this charged particle is moving along the direction of the magnetic field and the electric field. Okay, so if I talk about here the magnetic force, what is the formula? The formula is what here students? QVB sine theta, but here velocity and the direction of the magnetic field both are same. They are making how much angle? 0 degree. Even they can move anti-parallel also, not a problem. In that situation 180 degree. Okay, so let's take here. So what this will become here? This will become here 0. After that, if I talk about here the electrostatic force, what will come here? It will come here anyhow. F is the QE. This is the only what magnitude I have written here. Okay, even if I write here the in terms of the vector form. So this resultant force will be what here? This will be, as I have told you very well, Fm plus Fe here. So magnetic force how much here? 0, null vector. Okay, and what is this here? Positive charge particle means Q into E. So you can see very well the net force is the Q into E. So after that, if I write here, let's take for example, if I write here one more thing, let's take acceleration. So acceleration, what it will come here? We can write here force by mass here, and we can write here, see, QE by M. That means under the application of this electrostatic force, what will happen that here? The charged particle will accelerate along the direction of the water electric field. That means when it will accelerate, what we can tell? Its speed will change, or we can tell velocity will also change, because direction is same, but the magnitude is changing, the speed is changing. So what will happen that here? Speed will change, momentum will change, and kinetic energy, that will also change here. Na? So let's see what is given here. See, hence particle will pass through the fields following a straight line path with a change in its velocity. Direction is same, but the magnitude is changing because speed is changing, and momentum will change anyhow, and the kinetic energy will also change. Remember that here, students, here. Okay, so when they are moving in a combined electric field and magnetic field, what will happen? All these parameters will change. Remember that. Why? Because of which force? Because of the electrostatic force here. Okay, magnetic force is 0, but electrostatic force is there. Okay, great. Now students, let's see, move to the next case, case number 2. Very, very important case. So see here, when VE B are mutually perpendicular, then moving positively, na? By default always positive, but this case is always specifically for the positive. Positively charged particle will experience magnetic force in upward direction, while electric force in a downward direction, as shown in figure here. Okay, so here I have taken here the situation. This white color crosses are there, na? This is called here the magnetic field here. Okay, this is the magnetic field. What is this here, students? Say this is the magnetic field. Okay, and let's take here charged particle is there now, and this charged particle is having the velocity along x direction. Magnetic field in which direction? Inside the board. That means along a negative z axis. Okay, and I told you very well, the positive charged particle will experience force in the direction of V cross B. Now, so let's take V along x axis, magnetic field inside negative z axis. So V to B. What will happen that here? In this direction, what will happen? The magnetic force will be there, Fm. Okay. Similarly, you know very well, both V, E, B all are mutually perpendicular. So V, positive x direction, B in which direction? Negative z direction. To balance the force, this electric field I have applied in a which direction? Negative y direction. Okay, because I am always following the basic mathematical coordinate system here. Okay, like x axis, y axis towards you, z axis. This is the thing is there now. So if you will see very well here, this electric field in a downward direction. So what will happen that here? There is the one electrostatic force in downward direction is there. Why? Because which charge is there, students? Positive charge is there. So what will happen that here? The three situations are there in this situation. Let's see the first situation. First situation, see. Charge particle will move in straight line path if Fe equal to Fm. So you can see very well, if Fm and Fe both are equal, net force will become 0. That means what will happen? Under the absence of external force, the velocity will be constant. Now, so what will happen that here? It will keep on moving a straight line path undeflected. So here I can write here if Fe equal to Fm, that means I can write here, see, this is the QE, Fm how much here? QVB sine. Angle between V and B how much here? V along x-axis, B along negative z-axis. That means it will be how much here? 90 degrees there. Okay. So both the sides, remember that here, see, this Q and this Q is the cancel. So I can write here, see, this E equal to V into B. So from here, what is the velocity? Velocity is given here V equal to E by B. Okay. So when the velocity is V equal to E by B, then in a mutually perpendicular field, the charged particle will move in a which direction? Straight line direction, straight line motion. Both the forces are balanced. But let's take if in case the force is not balanced, In that situation, what will happen that here? Let's take here case 2. Charge particle will move in curved path upward if Fe is less than Fm. So you can see very well, I have told you very well, no? This is the velocity and magnetic field anyhow inside the board. So magnetic force in which direction? Which charge particle is there? Anyhow positive. So this is the direction of water magnetic force, and this is the direction of water electrostatic force, because we have applied the electric field in a downward direction. So see which arrow is the more? You can see Fm is more, Fe is less, is it? So in this situation, what will happen that you'll see? This is the QE is less than QVB sin 90 degree. Q and Q anyhow cancel. So what we can write here in this situation? E is less than VB. So hence V is greater than E by B here. Okay. What is this here, students? V is greater than E by B. So in this situation, what will happen that here? When V is greater than E by B, in that situation magnetic force is more. Okay. And the charge particle will move in a which direction here? See, I can draw here. See, like that the charge particle will move here. Is it like this? Like this. Now just like a arc, circular arc, it will move upward here. Okay. Remember that here. Third case, see here. Charge particle will move curved path downward if Fe is greater than Fm. Now let's see here what we can write here. See, it will become here. See, QE is greater than QVB sin 90 degree anyhow. Correct now. So again this Q and this Q is cancel. So what we can write here? Hence, or like this here. See, E is greater than V into B. Okay. So students here, this V will become here V less than E by B. So when V less than E by B, that time which force is more? The electrostatic force will dominate. Let's see here, please. Again see here. This is the velocity V. Now this is the velocity V. Magnetic force anyhow inside. Now you can see here the cross, and then what is there? In a similar way, the magnetic force is upward direction, V cross B. Is it? And let's take here perpendicular. Na? So electric field, let's take here downward direction is there. So what will happen that here? This is the electrostatic force downward direction, Fe. Na? Fe. So in this situation, you can see very well which force is more, Fm or Fe. The Fe is more than Fm. Okay. So in this situation, what will happen that here? Students, see, as this force is more, what will happen? The charge particle will move in a which path? Curved path. It will move here. Is it? So see here, this is there, na? Like that. See here, let's take like this. It will go here. Okay, because velocity is this side, na? So just like a curved, it will go here. Okay, and this is possible when V is less than E by B. Kindly see very well. So when both the forces are equal, V equal to E by B, and other these two cases are there, they may ask. They may give charge particle like proton, neutron, alpha particle, and they will ask a radius of curvature and all that. Basic will be this only. Okay, now see. This principle is used in a velocity selector device here. This principle is used where? In a velocity selector device. So when V equal to E by B, straight line path. When V greater than E by B, curved path upward. When V less than E by B, curved path downward. Used in a velocity selector device. Remember that here. Okay. After that, now let's see, we are going to solve very basic question. See, came in a J 2007. Important for NEET and J exam also. So see here. A charged particle with the charge Q enters a region of constant, uniform and mutually orthogonal fields E and B with a velocity V perpendicular to both E and B, and comes out without any change in magnitude or direction of V, then how much here? So see here, the direction is not changing. That means it is moving in a which direction? It is moving in a straight line direction. Okay. And for that, what I have taught you, the formula should come V equal to E by B. But here we have to write in a which form? We have to write here in a vector form here. Okay. So students, remember that here. One thing here, let's take for example, if I take here anyhow, this is the magnetic field inside the board, na? And let's take charge particle is I have taken positive, and velocity in this direction. So you know very well what will happen that here. This is the direction of the, you know very well, now you are intelligent, Fm. Is it? And let's take here, I told you very well, let's take here this one. Electrostatic force is downward here. No? Electric field is downward. So in that situation, what will happen that here? See, this electrostatic force will be downward here. Okay. And anyhow, this charge particle Q is there. Now let's take here. See here, this charge particle Q is there. So what will happen that here? What is the direction of the velocity? You see very well here. I will just write here the direction of the fields. Okay. So see here, this field B is inside, okay, and this electric field in which direction? Electric field in this direction is there, okay, and just let me just do little bit changes here, see, okay, see. So this is the B, and what is the direction of the velocity? We can tell here the velocity in this direction is there, okay. So just use the basic V. How to get it here? To get the V, you have to take E to B. You have to curl your finger from E to B, because E downward, B inside. So E to B, then only you will get the velocity. So I can tell here, the students say the direction of the V is along where E cross B. The direction of V is along where E cross B is there. Okay. So from here, remember that here the velocity V will come what here? See very well. Wherever E cross B is there, here you can see very well. See, E cross B by, now the question arises, by B square or by E square. For that we should know this formula, E by B. Make sure that here this will be B square here. This will be what? B square. How can we tell like this here? How can we tell like this here, please? If in case I take the magnitude here, mod V. So mod will be what here? See, mod of E cross B by B square here. E and B both are perpendicular, so EB sine 90. So EB and by B square here. And what will happen that here? See, this B and this B cancel. So what is coming? It is coming V equal to E by B. Is it? That means E cross B by B square is the correct option. So which option is correct is there? The correct option is here option B. And remember that here, this formula E cross B by B square is applicable even when the charge particle is positive or the charge particle is the negative. When the charge particle will be negative, this FM and FV direction will interchange. But when you will again apply the right hand thumb rule, again you will get here the same formula here. Okay, can you see here? Is it so? This is the J 2007 question. Now let's see here, students. The next question is the NEET 2011 question is there. Now let's see here, very basic question. See, a uniform electric field and a uniform magnetic field here, okay, are acting along the same direction in a certain region. If an electron is projected in the region such that its velocity is pointed along the direction of the fields, then the electron, and here what is there? Four options are here. So you know very well the electron is having the which charge? The electron is having the which charge? Negative charge here. Okay. So see here this. So students, you can see very well here. See, this is my fields. Magnetic field I have taken here B. Now, and if I talk about here the electric field, see here, this I have taken pink color. This is the electric field is there. And let's take electron is there. So electron is having which charge? Minus charge. I have written here minus q, and this is the direction of the velocity. Now, this is the direction of the velocity. This is the direction of the velocity along the direction of the velocity v. Is it? So in this situation, students, what will happen that here? See here, if I write here the magnetic force. Now first let's find out the magnitude. Okay. So what will become that here? See, electron is the qvb sine theta. Now, so qvb sine velocity in which direction? Along the direction of the magnetic field. Is it? So how much force is there? Magnetic force? 0. Okay. If I talk about here the electric field, electrostatic force. So here what will happen that here? Remember that here the charge is the E and the electric field is E. So what we can write here? Electrostatic force is E into E. That means electrostatic force it will experience here. Now, so students, if I talk about here the resultant force in a vector form. Resultant force in a vector form. So what is this here? See, magnetic force plus electrostatic force here. Magnetic force, how much is here, students? Here, see, 0 plus electrostatic force. Electrostatic force means now we have to take, whenever we are writing here the direction. So direction means electron is having negative charge. So minus E into E. This is the resultant force, Lorentz force here. Okay. So if I write here the acceleration, what is the acceleration formula? Vector F by m. So what is the vector F value? Minus, so minus E by m. Try to understand here, this minus sign is very, very important. This minus sign is telling that here vector A and vector E both in which direction? Opposite direction. So you can see very well, vector E is right side. That means acceleration this side here, and anyhow velocity right side. So you can see very well here, A and V both acting in which direction? Opposite direction, because V is the right side, and acceleration acting opposite to the electric field direction, that means left side. And we know very well, when A and V both in which direction? Opposite direction, what will happen to the speed? Speed will anyhow decrease. So which option is correct here? Will turn towards right of the direction of motion, speed will decrease, speed will increase, all is there now. So correct option is here, option B is the answer. Speed will decrease, speed will decrease here. Okay, great. Now let's see, next question is there. See here, the question is J 2023. See, a particle of charge 16 into 10 power minus 16 coulomb moving with velocity 10 meter per second along x-axis enters a region where magnetic field of induction B is along the y-axis and an electric field of magnitude this one is along a negative z-axis. If the charged particle continues moving along x-axis, the magnitude of B is how much here? Okay, so the charged particle is keep on moving along the same x-axis here. Okay, so see here please, the charged particle Q is here. Okay, and this is moving along which direction? Along y direction here. Okay, along this x direction here. Is it like this? Like this it will keep on move. No? Like this it will keep on moving here, like this. It is keep on moving here. How it is possible? Because see here, electric field they have given in a which direction? You can see very well here, electric field of magnitude along a negative z-axis, negative. So see here please, this cross inside the circle, electric field here, E. This is electric field. Magnetic field in which direction here? Along y direction, this is the magnetic field is there. Okay, so in this situation students, if I will calculate here the what to tell, magnetic force V cross B. So see here, V cross B out of the board. Now see here please, I'll draw here. Okay, out of the board is what here? This is the magnetic force here. Try to understand the basic. Now V cross B out of the board. And now electrostatic force in which direction? Electrostatic force in which direction? See, electric field is inside the board. So electrostatic force is also in which direction? Inside of the board here. Now here things will happen inside of the board. Okay, this is the electrostatic force is there. Now you think magnetic force is out of the screen, electrostatic force is inside of the skin. Okay, so this one force and this one force, both the forces should be what? Balanced. Both the forces should be balanced, because magnetic force along positive z direction, electrostatic force along negative z direction. When both will balance, then only the charged particle will keep on move along which direction? Keep on move along the x direction is there. That means here also what is the basic is there? Remember that here both the forces should be balanced. So what we know very well here, this Fm should be equal to Fe, and according to this what is the V? You know very well, V equal to E by B. V equal to E by B, is it? So from here we can write here what is the value of the B in the question they are asking, B value. So what is B? You can see from here, B is the E by V. Okay, now very easy. What is the value of the electric field? They have given here the value of the electric field. How much is given? 10 to the power 4 volt per meter here. So 10 to the power 4. Speed how much is given here? 10 meter per second. How much is given here? See, 10 meter per second. So by 10. So 10 to the power 4 by 10. What will come here? 10 power 3 unit of the B. We can write here Tesla or Weber per meter square, also not a problem. Okay, so this is the answer is there, B. B is which direction? Along y direction, 10 to the power 3. So correct option is here, option C is the answer. Okay, so understanding the direction is the very important. Now next one, let's see here students. This question is also came in a J 2017, important for NEET and J. So see, in a certain region static, electric and magnetic fields exist. Okay, the magnetic field is given by this one here. If a test charge moving with a velocity, this one experiences no force in that region, then the electric field in the region is how much here? Main thing is that the test charge is not experiencing any force here, and both the fields are there, so both the forces should be also there. Okay, so remember that here the basic is what here? The net force. Net force what is coming here? Remember that here this is the electrostatic force plus magnetic force is how much here? 0, because charged particle is not experiencing any force. Okay, so from here I can write here, see, this electrostatic force is given here, see it, QE plus here what will come here? QV cross B is equal to how much here? 0. Okay, because we have to calculate here the electric field. So you can see very well here, if I take here Q common, so it will become here what? vector E plus V cross B. Is it? And equal to 0. Anyhow, what will happen, dear students? This Q cannot be 0. So from here I can write here, hence vector is how much here? Vector E I can write here minus of V cross B. What is this? Minus of V cross B, because this thing should be 0. Then only net force 0. Okay. So minus here. V cross B formula, what is given here? See, V cross B. No? So vector V is there. I write here the determinant. So see, coefficient of vector V is here, V naught. For vector B, what is there? B naught here. And then other things I will write here in a determinant form is there. I cap, J cap, K cap. Okay. So first we have to write here the coefficients of vector V. This is the coefficients. So 3 minus 1 and here 2. Anyhow, V naught came outside. Similarly, for vector B, what is there? This B naught came outside, and what is given here? 1, and here 2, and here it is what is given? Minus 4 is there. Now we have to just solve this here. Okay, so it will become here minus V naught, B naught. Okay, and when you will solve here, I cap. I cap, what will become here? When you will simplify this, when you will hide all this part and all is there now. So minus 4, minus 1, 4. 4 minus 4 it will become here. What this will become here? See, 4 minus 4 minus J cap. So for minus J cap, what will happen here? Hide this J cap part. So 3 into minus 4, minus 12, and 2 1 jar 2. So minus 12 minus 2, it will become here. What are the students? Minus 14. Very easy. Plus K cap. K cap, what will happen here? Hide this 3 into 2, 6, and this one 6 minus minus 1, 7. So it will come here 7 here. Now, so after that, you just simplify this here. What will come here, students? This vector V will come here minus V naught, B naught, and in bracket here. Okay. So anyhow, coefficient of I cap is 0. So 14 J cap. Okay. What is coming? 14 J cap, and here how much is coming here? Plus 7 K cap here. Okay. See, plus 7 K cap. Now this is the electric field. So which option is correct here? Kindly see very well here. Here see, this minus is there. Now this option is correct. Is there? Now this happened by mistake here. Okay, so see, this option is correct. Can you see very well? Is it? So students, I hope so. This video based upon the Lorentz force cases and the questions are very clear to you. Keep studying, keep going.